In this video, we're going to review how to name covalent compounds. In the last video, we briefly saw how to name covalent compounds with a few examples, and we also saw how to name molecular elements or polyatomic elements. So just a quick reminder that when you're naming covalent compounds, you need to use the Greek prefixes to indicate how many of each atom you have in the compound. So if you have, let's say, 4 atoms in the compound, you'd have to use the Greek prefix tetra. If you have 1, you'd use mono. Unless the first element is 1, you wouldn't use mono, but you'd use all other prefixes. So we'll do a few examples together to make sure we understand that concept. So here we have CO. So we have 1 carbon. Because the first carbon is 1, we're not going to put mono in the front. And we have 1 oxygen. Now, when you're naming covalent compounds, the first element, you don't change its ending. You leave it as is, but you change the ending of the second element. So oxygen becomes oxide. And since we have 1, we use the prefix mono. Now, usually when you have 2 vowels that follow each other, you drop the vowel of the prefix. So that way it's not carbon monoxide, but rather it's carbon monoxide. The exception is if you have the letter I, then you wouldn't want to drop that vowel. So for example, if I had, let's just say, Cl4I3, so here we have 4 chlorines. Let me just make that a proper subscript here, and 3 iodides, so I'll make that a proper subscript as well. So here I have chlorine. Now I have 4 chlorines, so I'm going to use the prefix tetra, so it's tetrachlorine. And I have iodine, but I changed the ending to IDE. And I have 3 of those, so I'm going to have tetrachlorine triiodide. So when the vowels that follow each other, and you have a vowel as a prefix in the prefix, that's I, you're not going to drop that I. Let's do one more example here together. We will do, let's do ClO7. So notice that we have 1 chlorine, so we write chlorine. Because the first element is the one that's 1, we're not going to use mono. And we have 7 oxygen, so the oxygen gets changed to oxide, and we have to use a prefix hepta, which means 7. But notice that there's 2 vowels following each other, so we drop the vowel in the prefix heptoxide. If it was an I there, you would have left it. So for example, trioxide, but it was an A and an O, so you drop the vowel in the prefix. So again, when you're naming the covalent compounds, make sure you use the appropriate prefix. Don't use mono if it's for the first element, but the first element will have a prefix if it's any other number than 1. So if it's, for example, here, P2O3, let's quickly do that one here. We have the first element is phosphorus. We don't change the ending of the first element. There's 2 of them, so it's diphosphorus. There's 3 oxygens, but the oxygens become oxide. And we have 3, so we use the Greek prefix tri. So we have diphosphorus trioxide. The reason I didn't drop the I is because that's the exception to dropping vowels. You leave the I there. But if it was an A, you would have left. If it was an A, you would have dropped it. If it was an O, you would have dropped it. But the I you leave as is. So here we have diphosphorus trioxide. And so that was a quick review of how to name the covalent compounds. Now we're going to take a quick look at how to write formulas for covalent compounds. The formula writing for covalent compounds is a little bit easier than writing for ionic compounds, because you don't really have to do a crisscross. You don't have to do a charge balancing. You really just write the formula based on the prefix that's provided. So it just really requires you to know what the prefix is. So here we have diphosphorus trichloride. So you write the symbols of the elements side by side, and then you just put the subscripts based on the prefix. So the diphosphorus part means that there's 2 phosphorus atoms, and the trichloride part, the tri, means that there's 3 chlorines there. Now, you want to make sure, though, that for covalent compounds, you do not reduce. So for ionic compounds, you used to reduce if you could. But when you have a covalent compound, you cannot reduce. So for example, let's say you had disulfur dioxide. If you had disulfur dioxide, you have S and you have O. You have two S's and two O's. That's based on the prefix. Now, if this was an ionic compound, you would reduce. You divide by 2 and you get SO. But when you have covalent compounds, you do not reduce. You write it as you see it. So we'd leave it as S2O2. So simply write the symbols side by side as the order in which they appear in their name, and then put the numbers based on the prefix that's provided. Let's try this one here, nitrogen dioxide. So if it's a covalent compound, you would know that because there's two nonmetals, nitrogen and oxygen. Now notice there's no prefix in front of the nitrogen, which means that there must be one, because if there's no prefix in front of the first element, it must be the mono, which we don't put. So we have nitrogen, there's only one, dioxide, so that's an oxygen. The di means there's two, so we have NO2. You can do the same thing here, nitrogen triiodide, same concept. You have one nitrogen, you have iodide. Now it says tri here, so that means we have three, just like that. So covalent compounds are a little bit easier to write formulas for. No crisscrossing, no reducing. You simply use the prefix that is provided in the name in order to put the correct number of atoms. Make sure you memorize what the prefix means. So mono all the way to deca, meaning 10. And make sure that you do not confuse these rules with the binary ionic compound rules. You should not start using these prefixes for ionic compounds. So once again, if you see something like, let's say, Mg, F, you would not name this magnesium difluoride. You would simply name it magnesium fluoride. So no Greek prefix for ionic compounds, only for the covalent compounds that you've seen here.